What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice multiplying polynomials using an area model, which is sometimes called the box method. It looks like this, so if this looks familiar, you're in the right place, and if it doesn't, I hope you still stick around and learn this method. You may like it better than the one you currently use. So first let's quickly review the last video. We've used this method to multiply binomials, so let's quickly review that because we're going to extend that to polynomials like this example. So this method relies on two key conceptual ideas. One is that the product of two quantities, right, two quantities multiplied together, is equal to the area of a rectangle where one of those quantities is the length and the other quantity is the width. So specifically with this example, x plus 3 times x minus 5 is equal to the area of an x plus 3 by x minus 5 rectangle. Okay, first key idea. Second key idea, the area of this rectangle is the same as the sum of the areas of these four sub-rectangles. All I did was I took the area and broke it up into four pieces. If I add these four areas together, I get the whole. So should be pretty straightforward conceptual ideas. Together, we put these ideas together and we find the areas of these smaller rectangles by just multiplying. X times x, this area is x squared. X times negative 5, this area is negative 5x. 3 times x, this area is 3x, and then 3 times negative 5, this area is negative 15. We can combine some like terms because remember what we said. This product is the same as this total area, and this total area is the same as the sum of these four areas, which we just found. So we have two like terms here, 3x and negative 5x, and we can combine this as x squared minus 2x minus 15. Boom. And that's how the area model works. So now let's just extend this. We're going to literally do the exact same thing. The area model is so easy to extend and generalize out further. You can even use it for division. That's why teachers really like it, because it's a consistent model we can use for a lot of different things. So remember, this product is equal to the area of this rectangle, which is x minus 5 by 3x squared minus 2x plus 2. So the only difference now is instead of having these four sub-rectangles, we're going to end up having 6. We want to break this up by term, right? So we have 1, 2, 3 terms here, so we're going to have 3 columns. We have 1, 2 terms here, so we're going to have 2 rows. Boom, 6 sub-rectangles. Let me make this one a little bit better. Awesome. All right, so now remember, the product of this is equal to this full area, which is equal to the sum of these 6 areas. So we're going to find these 6 areas, add them up, simplify if we need to. Boom, that's going to be it. All right, 3x squared times x, that's 3x cubed. X times negative 2x, that is negative 2x squared. X times 2, that is 2x. Negative 5 times 3x squared, well, negative 5 times 3, that's negative 15, and the x squared is chilling. Negative 5 times negative 2x, so negative negative, that's positive. 5 times 2 is 10, x is chilling. And then negative 5 times positive 2 is negative 10. Here's what I like to do. I like to combine like terms in the actual rectangle here. I'm going to end up adding this plus this plus this, right? Adding them all together. Let's go ahead and identify some like terms before we even write all that out. These two are like terms, and the 2x and the 10x are also like terms. So we can go from this straight to the simplified version. We've already done the multiplying. We got to do the simplifying, and we could go straight to the simplified form by writing 3x cubed, right? That doesn't have any other like terms, so that's just by itself here. And then what do we have next? We have negative 15x squared minus 2x squared, okay? So we're subtracting 15 of these x squareds and then taking away 2 more, and that's a total of taking away 17 of those x squareds. That's how we can think about this conceptually, right? This is adding 10 x's. We're adding 2 more, so we're adding a total of 12 x's. And then there's a minus 10 at the end. Boom. We have multiplied. We have simplified. It's that easy. We're good to go. I love the area model. Hope you do too. Pause the video at this point. Try this example on your own. It's very similar. Pull out a pencil and paper. See if you can get it. Get the final answer. Simplify. Then compare your work with my work. All right, let's jump right into it. This product is the same as the area of this rectangle here, where the width is 2x squared minus 3, and the length is x squared minus 2x plus 4. Boom. All right, we're going to break this up. Looks very similar to our last example where we have 3 columns, 2 rows. We have 6 total rectangles. All right, let's start multiplying. Let's start finding these sub areas in here. 2x squared times x squared. That is 2 times x to the fourth. This is two x's multiplied together. We are multiplying two more x's with that for a total of 4 x's being multiplied together. You can also think of your exponent rules. Same basis, we add exponents. All right, and we have 2x squared times negative 2x. Negative 2 times 2 is negative 4. X squared, we're multiplying one more x for a total of 3 x's being multiplied together. That's x to the third. And then here we have 2x squared times 4, which is 8x squared. Here we have negative 3x squared. Boom, that's really easy. Negative 3 times negative 2x. Negative negative is going to make a positive. 3 times 2 is 6. X is just chilling. Negative 3 times 4. Negative positive, so it's negative. 3 times 4 is 12. Boom, let's identify some like terms. And we're going to add all these together. We got a fourth power here. That's the only one. So that's going to go ahead and be in our final simplified form here. So we got that taken care of. All right, I see a negative 4x to the third. Wow, there's no other third power. Boom. So we're going to go ahead and write that down. Negative 4x to the third. Boom. All right, what about squareds? Oh, we got two of those. 8x squared minus 3x squared, and that gives us plus 5x squared, right? 8 minus 3. Boom. So we got those. Took care of those like terms. And then we have 6x and minus 12. So plus 6x and minus 12. Boom. We multiplied. We simplified. Killed it. Awesome. Let's do one last example. This time it's going to be a trinomial times a trinomial. Crazy example. So that's the main difference. One difference, obviously, we have k instead of x. That's literally no difference. It's just a different letter. I just want to throw it in there because sometimes you'll see that. So don't freak out. And then we have two trinomials. That is kind of a big difference, right? So we're going to write our broader rectangle here that we're finding the area of. And I'm going to kind of have to write a little bit small. We have 2k squared here, and then we have plus 4k, and then we have minus 3. So we're going to have 3 rows, and then we're also going to have 3 columns because this is k squared minus 6k, minus 6k minus 1. Boom. So we have 3 rows, 3 columns. Let me see if I can draw it out here fairly neatly. We're going to be a little bit tight on space. That's okay. All right, at this point, now that I've got it set it up for you, see if you can pause the video, especially if you didn't last time. Pause the video, try this on your own, multiply this out, simplify, get a final answer. All right, let's jump into it. Hopefully you're checking your work. Here we have 2k squared times k squared. That is 2k to the fourth. 2k to the fourth. Here we have 2k squared times negative 6k. Negative 6 times 2, that's negative 12. K squared times k, that's k to the third. And here we have 2k squared times negative 1. That's really easy. That's just negative 2k squared. Boom, one row done. 4k times k squared. The 4's chilling. K times k squared is k to the third. 4k times negative 6k. 4 times 6 is 24. It's going to be negative because there's a negative and a positive. So negative 24. And then k times k. K squared. Boom. Awesome. 4k times negative 1. That's negative 4k. All right, last row, we're killing it. Negative 3 times k squared, that's negative 3k squared. Negative 3 times negative 6k. Negative negative makes a positive. 3 times 6 is 18. And we got the k chilling like a villain. Finally, negative 3, negative 1. 2 negatives make a positive. 3 times 1 is 3. And boom, baby. Beautiful. All right, now we got to combine some like terms, see if we can get a final answer. I see only one k to the fourth term. So I'm going to write that in our final answer here. That was an ugly equal sign. There we go. All right. 2 times k to the fourth. Boom. All right. We got that done. All right. What about k to the third? I got 1, 2 of those. 1, 2. So I got 4k to the third minus 12k to the third for a total of minus 8k to the third. Awesome. 4 minus 12 is negative 8. So that's the new coefficient. Now look at these k squareds. 1, 2, 3. Let me make my circles a little better. I might just erase them, actually. We're just going to identify these are the 3 because I don't want to cover up these negatives. We have negative 3k squared, negative 24k squared, negative 2k squared. So let's see. Minus 3 minus 24, that's minus 27. And then minus 2, 4, that's minus 29. Minus 29k squared. So where are we at so far? We did that. We did both of these. We did all 3 of these. And now we're left with 18k and negative 4k. We can combine those. That's 14k. And then plus 3 at the end. And this is going to be a pretty consistent pattern where you're going to have these like terms and these diagonals, right? So this is like the k to the fourth diagonal. This is the k to the third. This is the k squared. This is the k. And then we're left with the constant. Pretty consistent pattern you're going to see a lot as you do examples like this. Awesome. Hopefully you enjoyed this video. Hopefully it helped. If it did, like the video. If you have a question, leave a comment. If you need more help, go to my channel, go to my playlist, click through the playlist, click subscribe to support me. Do all that stuff, and most importantly, keep flexing those brain muscles, and I'll see you on the next video.